Hi everyone. Now I will answer the questions about the section 2. The mostly incorrect answered questions of test 4 and test 5. The first question is question number 6 in test 4. The points A and B represents horses on a carousel. So here is point A, here is point B. Which of the following is wrong? Questions, which of the following is wrong? A. Angular displacements of the horses are equal. Yes, the carousel is a rigid object and every point on that rigid object displaces with the same angular displacement because it's a rigid. This is correct. This distance traveled by the horses are equal. This is impossible because distance traveled by the horses are different because horses are at different distance to the axis of rotation. The horse outside travels a longer distance than the horse inside. This is incorrect. This is wrong. The tangential speed of the horse B is greater than horse A. Tangential speed of horse B is greater than horse A because horse B is farther from the center of rotation. So then outside horse will travel faster than the inside horse. So this is also correct. The angular speeds of both horses are equal. This is also correct because this carousel is a rigid object. For its rigid object, all angular quantities for every single point, every horse is the same. This is also correct. So incorrect answer is B. And question number 21 is another mostly incorrect answered question. When a wheel rotates about a fixed axis, all points on the wheel. So wheel is a rigid object. First, get it. We know that for a rigid object, its shape is not changing, it's rotating. Every point on this wheel will rotate with the same angular quantities, same angular speed, same angular displacement, same angular acceleration. So A, same angular speed, correct, but same tangential speed is incorrect. So a part of this sentence is correct, but other part is wrong. That's why this cannot be correct as choice. Same tangential speed, no, tangential speeds are different depending on the radius and distance to the axis of rotation. Same angular speed, this is correct because every point has the same angular speed, same angular displacement, same angular acceleration for a rigid object. So choice is going to be C. Question number 8. What is the time's angular acceleration in radian per second square if the tangential acceleration at the point of radius 15 centimeter is 9.4 times 10 to the power negative 2 meter per second square. This is tangential acceleration AT. And radius is given r is equal to 0.15 because centimeter must be converted to meter. Calculate angular acceleration alpha. We know that AT is equal to r times alpha. We will calculate alpha. So alpha simplify r by dividing r. R will simplify alpha is equal to AT divided by r. AT tangential acceleration is 9.4 times 10 to the power of negative 2 divided by r is equal to 0.15. So if we divide them by a calculator, 9.4 times 10 to the power of negative 2 divided by 0.15, which is equal to 0.627. 0.627 is alpha. 0.627 radian per second square. So if you round it, it's going to be 0.63 radian per second square. So choice is B. And next question is question number 12. For a rotating object to remain rigid, again, it's talking about rigidity, as does a bicycle wheel. Every portion of the object must have the same. We know that for condition for rigidity is what? So every portion, every point on this rigid object must move with the same angular speed, same tangent, same angular acceleration, same angular displacement. Tangential speed, no, tangential speeds could be different depending on the distance to axis of rotation. Tangential acceleration can be different. Displacement, but this is talking about linear displacement, can be different, but angular acceleration must be the same for every portion of this object because this object is rigid. Again, 13. Two horses attached to a carousel at different distances from axis of rotation. Again, carousel is a rigid object. This question is also about rigidity. For a rigid object, angular quantities are the same for every point. So there are two horses at different distances. So if they are at different distances, their tangential quantities must be different. But angular quantities will be equal. They have the same angular speed, correct. They have the same angular acceleration. This is also correct. And same tangential speed, no, because their distance to axis of rotation is different. The horse outside will have a greater tangential speed than the horse inside. So this is incorrect. It is wrong. So both A and B are the correct choice. And question number 5. Test number 5, most incorrect answered questions. First one is third, correct question number 3. A satellite traveling at a constant orbital speed 5 meter per second represents tangential speed. So even if it's called orbital speed, look at the unit is meter per second. It is linear quantity, so with tangential speed. Is in a 3.14 kilometer circular track. This is defining the circumference of the circular track. And it's from here to there, length of the circular track. Circumference is equal to 3.14 kilometers. And arc length of one circle is called circumference, remember? So this is not radius. What is the centripetal acceleration? AC is the question in here. So first we should get what R is. But kilometer must be converted to meter first by multiplying 1000. 3.14 multiplied by 1000. So we convert it to kilometer to meter. 3140 meters is the circumference or arc length for one revolution. So then we know that S is equal to 2 pi r. By this equation, first we will get what r is. Circumference 3140 meters is equal to 2 pi is 6.28 multiplied by r. So divide by 6.28, divide by 6.28. So you are going to calculate what r is. So r is going to be 3140 divided by 6.28. It is 500. So r is equal to 500 meters. Now we can calculate the centripetal acceleration. Vt squared over r. Vt is tangential speed 5 squared. R is 500, which is 25. 5 squared is 25 divided by 500 is 0.05. 0.05 meter per second squared. Choices B. There must be a correction in here. So 0. In the typing, there's a typing mistake. So 0.5 is it in the choice, but it's going to be 0.05. Question number 8. Describe the path of a moving body whose acceleration is constant in magnitude at all times is perpendicular to velocity. So when an object is moving on a circular path, only this is possible because when an object is moving on a circular path, its velocity is tangent, direction of the velocity is tangent to the circle Vt. So, and centripetal acceleration is along the radius, so these two vectors are perpendicular to each other, so perpendicular to velocity. Yes, whose acceleration is constant in magnitude, so acceleration is AC is constant in magnitude if Vt is constant, and perpendicular, these two vectors are always perpendicular to each other, so object will follow a circular path in this case. Question number 9. The angle between the direction of the tangential acceleration and centripetal acceleration. Centripetal acceleration is what? So again, let's draw the circle. Tangential acceleration is always tangent to the circle, and centripetal acceleration towards the center along the radius AC, and angle between them is 90 degrees. They are perpendicular to each other always. So D is the correct answer. And next one is question number 1. When an object performs uniform circular motion, the direction of the acceleration is in uniform circular motion. Uniform circular motion means so the tangential speed is constant. So if an object moves with constant tangential speed, so you can say that it's uniform circular motion. Direction of the acceleration. So if Vt is constant, this object will have only centripetal acceleration, and we know that centripetal acceleration always points towards the center of the circular path, so it's also acceleration of the object. So in the same direction of the velocity vector, no, velocity vector is tangent to the circle. It is not correct. In the opposite direction of the velocity vector, not correct. It's directed towards the center of the circular path. Yes, direction of the centripetal acceleration is the acceleration of the object. It's pointing it towards the circular path. Correct. Is directed away from the center of the circular path. It is incorrect. C is the correct answer. And question number 20. Give an example of a situation in which an automobile driver can have a centripetal acceleration but no tangential acceleration. No tangential acceleration means tangential speed must be constant. Tangential speed must be constant. So constant tangential speed, but centripetal acceleration only exists in circle. So then this automobile must be moving in a circle with constant speed. A car moving on a straight path, no, it must be circle. A car driving in a circle, correct. At constant speed, this is correct. Yes, seems to be correct. C, a car driving in a circle, but changing, no. If it is changing, there will be a tangential acceleration. None of them. Correct answer is choice B for this question. This is all about the section 2. There are some questions which is done incorrect, so I answered them. Now we continue doing the others, and then after each test, each section, I'm going to prepare a YouTube video file like this, and you are going to learn about those most incorrect questions. See you later.